Hello, students. We are discussing about regression, and let us continue our discussion with further that is regression in simple as a simple linear regression, then going forward as a multiple linear regression, and then basically we have multivariate as well. So, this particular session we will discuss on regression with the help of a data set which is called as Boston housing data set. So this Boston housing data set we will use. Boston housing data set. This is a famous data set used for regression problems, and that is a good thing that we are working on this. It has got some columns which I will speak about in some time. Before that, let us import the necessary libraries. So import the libraries, libraries, libraries. Okay. So let's import NumPy as np. Then let's go for import pandas as pd, and then we will also import matplotlib. So matplotlib, import matplotlib dot pyplot as pld. So this also we will import, and we will import the data set also. So import the data set as well. So we will import data set from sklearn, from sklearn.datasets datasets, import load Boston. So sklearn.datasets has got so many datasets, out of which one is Boston, and Boston is equal to load underscore Boston, and these brackets, this is going to help us with the dataset. So here we have the dataset loaded and some information about it we can see. Now let me display Boston dot data dot shape. So here we have the shape of the data set, which is 105 rows we have and 13 columns we have. So these many number of rows and columns we have in this particular data set. And let me show you the features or the columns inside it. So boston.feature feature names, this is going to show you the features. So here we have CRIM, ZN, Indus. So all of them have got some meaning. And the CRIM, that basically means that what is the per capita crime by that particular town. Then we have ZN. ZN shows that the proportion of residential land zoned for lots over 25,000 square feet. So for every 25,000 square feet, what is the proportion of residential land zoned? That is basically ZN. Then we have Indus, INDUS, that is the proportion of non-retail business acres per town. Okay, so that is industries basically. Then we have CHAS, that is Charles River dummy variable. If it is 1, that basically means that the tract bounds the river. If it is 0, that means the tract doesn't bound the river. Then we have NOx, that is nitric oxide or nitric oxide concentration per 10 million parts per 10 million. Then we have RM. RM is the average number of rooms per dwelling. Then we have age. So age is the proportion of the owner occupied units built prior to 1940. So how many, it is a proportion. Okay, age is the proportion of the owner occupied units built prior to 1940. Then we have DIS, that is the weighted distance of 5 Boston employment centers. So that is the distance from employment centers. RAD we have, that is the index of accessibility to the radial highway, that is RAD. Then tax we have full valued property tax rate per $10,000. Then we have PT ratio, so that is pupil teacher ratio by town. And then we have B, so that B is 1,000, where BK is the proportion of the blacks by town. Okay, so BK is basically 1,000 BK. So BK is the proportion of the blacks by town. Okay, so that is something. Okay, how many black people live there? So then we have LSTAT. So LSTAT is the lower status of population, and then these are the features actually. The target variable is medv, that is the median value of owner occupied house. So that is basically in $1,000. So whatever number is there, you can basically assume it that that number $1,000. That is how you can take it as. So this is about the columns which we have. Now let us move ahead and try to have data is equal to pd dot data frame. So we would like to have the data in the form of data frame. So boston boston dot data. So the data stays inside boston dot data. And what else I would like to have is data dot columns columns is equal to boston dot feature feature names. So that will become column. And let us basically have a look at head. Let's have a look at 10 of the columns, rows of this particular data set. So this is my data, or you can say this is my input data, input features, because here I don't have the output. The output is separately stored. Now what is the output? That is basically boston boston.target target. So this boston dot target is the output, and you can see these are some values. Now let me check that boston target dot shape. What is the shape of this? So the shape should be equal to the number of rows which we have in the input data, and you can see that it is 506, which is exactly same as what we had in the input data. So 506 was there in the input data also. Now what I can do is I can add up this particular variable in my data frame itself, so that I can have all the information at same place. So for that, what I will do is data of, this is the median value, but it is a price. So data of price, I'll be adding up a column named as price. So data of price is equal to, then I will be putting boston dot target, and let's basically have data dot head and check out what values does it contain. So you can see that we have the price value also attached to the data frame. Now let me basically do data dot describe. This is going to give me the basic stats of the data. So you can see that it gives us the count, mean, standard deviation, minimum, 25%, 50%, 75, and maximum. This is what it gives us. And count, everywhere you can see it is 506 count. That means this data is clean. There is no missing values into it, because we are able to see that everywhere it is 506. Okay, then standard deviation and mean, we understand. Mean shows the central tendency, central value, and standard deviation talks about the spread of the data. So this we have basically got. What next we can do is we can simply try to go for data.info, and it will give us the details of the columns, their data types, and whether null is there or not. So you can see here that we have total 14 columns starting from 0 to 13, and all of them have values in 500 not 50 not 5 not 6 rows, and their data type is float itself. So this is what we are able to see in detail. Now what we can do is we can basically have data in two formats. One should be input data and other should be output data. So if I want to have input data and output data, then basically what you need to do, so in that particular case, for input data, you can just have x, and x is equal to, you will get boston dot data. This is input. And what is output? The output is y is equal to boston dot target. So this is our input and output split into two parts, okay, x and y. Now what we will do, we will split this data into training and testing. So for that, split this data into training and testing. So how can we do that? So from sklearn from sklearn.model model selection. So from sklearn.model selection import, we'll be importing train test split. So train, this is okay, so train underscore sklearn dot, yeah, so train test split, yes, this is something we will gain from here, and I will now create x underscore train comma x underscore test comma y underscore train and y underscore test. So we have basically all these variables we'll create because we'll be getting the values into them. So here I'll be getting train underscore test underscore split split. So train test split, and in this train test split I'm going to pass so these brackets are not actually required, so let me just remove them. So train test split, what do I require here? So here I'll be requiring that how much data. Okay, what is our data? So the data is x and y, this is the data, and the test size has to be mentioned. So test size is equal to, I'm doing 0.2, that means 20%. So 0.2 basically means that 20% of the data I want to keep as test, and rest of the data will be as the train. So here I can also initialize random state. So random underscore state random state, and we can give it a value, let's say 0. So whatever value you want to give, you can give it to it. So now here basically it is getting executed. Meanwhile, I'll just write some print statements. So print, and here we have x train train. So the shapes we are printing, nothing else. So x train has got x train dot shap shape, and then we have print print. Here we will have x test, so x test test, and the same thing is going to happen here as well. Okay, so inside only I have to pass x test test. Okay, so x train and x test dot shap shape. So similar way, y train and y, okay, test you can put on here. So here let me put y train, and here also. So this x train should also be having this. Okay, and this is y underscore train, and this is y underscore. So y underscore test. Okay, so this is what we are going to see now. Okay, x train, y train. So you can see their shapes, and 20/80 is the ratio. Fine, so now we have the shapes. What else can we do? Now we can go for creating the model. Okay, and this is multilinear, because multilinear regression, because here we have multiple features, x1, x2, x3. So multiple features we have. So from sklearn dot so from sklearn dot linear model, import linear regression. Okay, and let me create lr linear regressor is equal to linear 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 regression. Then after that lr dot, I'll have to fit it. So I'll have to pass the x underscore train data and y underscore train data. So x train and y train we are passing. Okay, so control z, y train we are passing. And now what else? Now we would like to have the predictions. So y pred is equal to lr dot predict lr dot predict. Okay, so predict lr dot predict. Now in this particular prediction, I will put x underscore test. So x test is going to go there, and then it is going to display as the result. Okay, so print here y underscore pred result. And what is the result we are having? So you can see that it has made the prediction also, and it has brought up the result. Okay, so these results I can have them plotted in a graph so that I could see whether they are correct or not. So what I will do is I have the data frame, even that is not required. So what we will do is, here we will take up one column from x. So x, we have x underscore test. So this is X test where, okay, so this X is small. So let me just make that correction. Okay, so this is X test, and I just need, this is the first row of it, but I need all the rows, but only first column. All the rows and only, let's say, zeroth column. Let's just assume zeroth column. So this is what I needed, and this I will be passing in the creation of the map. Okay, the scatter plot. So what I will do is plt.scatter scatter, and here this is x test, and then y underscore test test. Okay, then plt.sc. So what I can do is, just below here only I can just write plt dot scatter scatter, and in bracket, so x test I'll take as it is, but y I will take here y taste. So here y is equal to, we can take any, so here we will take y is equal to train. Sorry, यहाँ पे we will have to take y underscore pred pred. Okay, so for pred we will see that how is it matching. So quite matching, you can see that both the outputs y test and y pred, they are quite overlapping. So this overlapping actually means what? That means the algorithm has made almost good corrections, good predictions. That basically means that now you can move ahead and try to evaluate. So evaluate the model. So how can you evaluate the model? You can evaluate by finding out the errors. So from sklearn dot, we will go for metrics. So from sklearn dot metrics import, we will import mean squared error and mean absolute error. So mean underscore absolute error and mean underscore square error. So mean absolute error and mean square error, these are going to tell you some magnitude of the errors. Okay, which looking at the diagram shows that it's not very high. It's not very very high. So print, and here we are printing MAE, mean absolute error. So mean absolute error is mean underscore ABSOLUTE absolute. Then this is one. Okay, mean absolute error. So inside this mean absolute error, I'll have to pass the y underscore test train, comma y underscore test test. Okay, so one is basically test, another is pred. So one pred we will put, okay, because it is about that only. So print again, here it will be MSE. Okay, and so MA is absolute value, the magnitude is always less, so this MSC magnitude should be higher than that. So mean underscore, this was absolute and this was mean. Okay, so AB, this was mean squared, SQUARED squared error. So here also we'll be passing the same things, that is y underscore tst test, and we'll pass y underscore pred pred. Okay, so here we have, I just did not put, yes. Okay, so mean squared error. So MAE comes as 3.84. Mean squared error performs square operations, and therefore you can see that its value is higher. So we can see that our model is, if I basically take MSE and that too as in terms of percentages, so 33.44 means the accuracy will be opposite of it, and it will be around 66 point something, maybe 55. Okay, so which is not a great optimized model. Okay, but it is able to now make a prediction. So this was about how basically multiple variables or multi-linear regression can work. So you can practice this particular notebook, type it and practice it on some other data sets as well. Keep learning. Thanks for watching.